what are the essential steps involved in creating an IP from scratch?
Yeah, so for the different steps, creating an intellectual property block involves first that you do a specification of your IP. So I will give you a high-level overview of the different steps. So for the specification, you have first to define the functionality of your IP, the performance, and the interface requirements of the IP. So this includes created a detailed specification document that outlines your IP features, such as the inputs, outputs, and operational parameters. So this is what is about specification, the first step. Once you have it, you move towards architecture design. So architecture design is to develop the high-level architecture of the IP. So at this step, you will define an overall picture of your IP with the different blocks and how they interact together. So it means to be clear, it means that you will decide the major components and how they interact, and you will clarify the data flow within the IP. So this is about architecture. And once you have it, you can start doing your RTL design. So you will, at this step, you will write the register register transfer level code, which can be in Verilog or VHDL. And as you did your architecture specification, you're able to split the job between the different members of the design team. So each of them will code the RTL level code of the different blocks. And of course, during this step, you will describe the behavior of your IP at the register level. Once you're doing the RTL design, the next step is the functional verification of your code. So you verify the RTL code to guarantee that it meets the specification. And for this purpose, you need to create test benches. And you need to run simulations to check the IP functionality under various conditions. So you have different steps. You can do some simulation and look at your chronogram visually for some little part of your design, or you can have some automation, and you need to have a good coverage when you're checking your design. So you have some mechanism in the test bench to be sure that each for instance, for a CPU job or whatever. So you need to be sure that each instruction is checked and each output meet the expected output. So this is for functional verification. Then once you did validate your RTL code, you go to synthesis. So in this step, you will convert your RTL code into a get level netlist. And during synthesis, you will optimize your design for area, speed, and power. And all those optimizations will be based on a specific target technology library for hard IP. Then you have design for test, DFT. So in this step, you implement the test structures. So it's at the same time than synthesis. You're doing some DFT structures such as scan chains. This guarantees that your IP can be tested during manufacturing. And it means that the inputs of your IP should be controllable and the outputs can be observable. And then, so I'm moving from soft IP to hard IP. Then you have the place and route, where you place the standard cells and you route the interconnects between them. Still, at this routing step, you are doing optimization so that timing is as expected frequency. Your IP is at the expected power, and you limit the area of your IP. Once place en route is done, you have sign-off checks to be performed. The first one is a sign-off timing analysis. So you do perform STA to guarantee that the IP meet the timing constraints given in SDC. And you do check and fix any setup or hold violations that you can see at this step. The second sign of checks is power analysis. So in this one, you will check the power consumption of your chip for different scenarios. And you have to check for voltage drop in your design versus the threshold given by the foundry. And you have to check also the electromigration to be sure that there is not too much current going through the wires. And the last one, which is also a very important sign of checks, is a physical verification. So here I'm talking about design root checks, DRC, and layout versus schematic, LVS, and electrical root check. So this is a physical verification. Then it's not finished because as you're creating an IP, you need to document it. So documentation is another step. You need to create a comprehensive document for the IP. You need to include the user manuals, integration guides, and test reports. And you may have to do also IP qualification to make your IP go through extensive testing and validation to ensure it meets required quality and reliability standards. So, for instance, you can think of automotive market where you have some ISO rules stamped to have for your IP. Space is another area where you need some specification and qualification. And the last step I could think of is integration and support. Once you sell your IP to a customer, you need to provide support so that they can integrate the IP into their larger systems, and you need to assist them with any issues that can arise during the integration process.
Yeah, that seems like a whole lot of experience. Uh, can we go to next question? That is, for long term success, should we target soft IPs or hard IPs, which are place and routed, or should we consider building verification IPs?
Yeah, so there is no simple answer to those questions because there are various parameters to consider. I will just let's start with a brief explanation about the IP concept and the different IP types and what are the advantages and lowlight of each of them. So when a company designs its own block that can be reusable and sell to different companies, we call it an IP, intellectual property, because the companies need to pay license and or royalties to make use of it. An example of IP I could think of is a Mali GPU from ARM or the Cortex CPU family from them too. So what is a soft IP? So soft IP is delivered as a synthesizable logic written in VHDL or Verilog, and it can be also delivered as logic net gets netlist 2, a generic logic. But soft IP is not optimized for a specific target technology. So this is a low light because it cannot be fully optimized. But the advantage is that soft IP offer more flexibility for the customer. Soft IP advantage is also that it's simpler to develop. So it means it's less expensive also because you don't have to make a test chip in each technology nodes to be silicon proven. It can be customized per customer requirements, which is another advantage compared to hard IP. For example, you can imagine that you are an IP provider for a memory controller, right? Then you can accommodate the entire controller to support the memory vendor, and you can do implementation of the features, and it will require minimal changes when you change the features accordingly to the customer wishes. So these are the advantages of soft IP I can think of. Now moving to hard IP. Hard IP is delivered in a gate level or a transistor level physical description, right? So it can be directly included at the physical design stage. So for customer, it's something quite simple to incorporate in their design during physical stage. Another advantage is that when you provide the IP, you don't reveal the source code of your IP. And another advantage is that it provides highest performance because it's fully optimized in terms of area, timing, and power for the specific process. Um, so those are the trade-off between soft IP and hard IP, right? Another concept is that your IP may be fully analog, such as phase lock loop PLL, low noise amplifier. It can be fully digital. It can be CPU, DSP, or it can be mixed signal, such as analog digital converter or SERDES. Uh, Generally, the analog digital and mixed signal logic are cores and are provided to chip makers in transistor layout format, GDS2. Because transistor layouts are designed with foundry specific process, the user will be forced to use this process for hard IP. Um, all the IPs are going to be part of system on chip or subsystems, so it should support easy integration for plug and play for the end customer. Verification IP. So verification IP is a separate business, right? This kind of IP is used to verify and ensure the quality, safety, and compliance of products. And it may include some standards, certification, and testing protocols. Those IP are essential in healthcare application, automotive, aerospace industries, and those who design soft or hard IP should not develop their own verification IP too. Usually, those are different companies because ideally the verification IP should be handled by another company to reduce the risk when you're verifying an IP. So now let's talk about the considerations for long-term success, which is your question. So the importance of each type of IP can vary greatly depending on the industry. For example, tech startup might prioritize hard IP to protect its innovation, while a fashion brand company might focus on soft IP to protect its design and brand identity. So I was talking about ARM, for instance. So they are providing various soft IPs for their CPU and GPU families. Hard IP can be resource intensive. So you need to be sure that the potential benefits justify the investment. And the best advice I can give you is to consult with IP professionals and conducting a thorough IP audit to produce valuable insights tailored to your specific situation. That's what I could think of.
Yeah, that's really cool, Bertrand. And can we just go to the next question?
Yeah.
And that was like many of our employees asked that uh, can you just show us an example architecture of an IP, and can you explain with that? That will be really helpful. And you know.
Yeah. So let's take an example. I don't know if the video will be fine if you can see it clearly. So, but I will explain anyway. So this is just a block level picture of serializer, deserializer, SERDES. So this one is a hard IP because it is done for TSMC. It's TSMC 7 nanometer nodes, and this SERDES, if we talk about specification, it's a 56 gigabit per second SERDES. So this is the block diagram. As you can see it in a documentation, for instance, at the beginning of the document, you can see this type of picture, or when a company promote an IP, you can see this type of diagram also on their websites or in a PPT presentation or whatever. So you have different blocks in this SERDES. So the pure digital, for instance, is a microcontroller, which is here, which is the brain of the SERDES. We have also so we have a reception line and transmission lines, and we have an analog front-end block here. So you have some analog part. We have analog to digital converter, and we have a DSP block. So what I can say here is that this IP is a mixed signal IP. Okay. So we have a hard IP, mixed signal IP, and there are various blocks. So there is also a finite impulse response filter. Sorry, the filter is here. We have a digital to analog converter here, and we have output drive voltage block here. And we have also some pseudo random binary sequence that can be also used on the different lines, transmission and reception lines. So this is an example of IP, and as you can imagine, so different designers will handle the RTL code and the implementation of those different parts of the IP.
Cool. Cool that we are appreciating that you took a photograph to show us. We are expecting a screen share, but this is really enough. Uh, Thanks for that. And we'll be moving to next question. Uh, for a company starting IP development, what would be a good first IP to target for quicker market entry and sales?
You need first to have a differentiator versus the competition. So you have to think about performance or features or price. So you need to target really what is a differentiator. And so you need first to analyze the market and see what you can offer that does not exist already, and what plus value can you give to versus the competitors. I would say targeting a simpler and less resource intensive IP can help achieve quicker results and build a foundational experience. You may focus on utility patents for incremental improvements to existing products or processes. They are quicker to develop and patent. You need to enter a market in expansion or a market with few competitors. You may also have some networking for a specific market, so you can capitalize on it. And I can suggest also to participate in consortiums handling norms such as PCIe norms. I would say also that an IP that targets healthcare application seems like a good start to me because it will give a good image for the company brand. And in healthcare, there are needs for better disease diagnosis, health monitoring, better tools to predict and cure disease. And there are plenty of biomedical sensors that interact with data processing digital blocks. And those systems for sure are making use of IP blocks. And my last advice will be to ensure the IP aligns with your company overall business strategy and goals.
Yeah, yeah, that's really good insight. And based upon this, what types of IPs are currently in high demand in semiconductor market right now?
As of today, there are a lot of CPU. From you have Ryzen 7 from AMD, Intel Core i9, so CPUs. You have high-speed SerDes. There are network on chip interconnect IPs too. There are plenty of also there are plenty of controllers. So a controller for PCIe, for instance, you have PHY for PCIe. I can think of UCIe PHY also. We have Ethernet multi-protocol PHY. High bandwidth memories also is really a trend. Low power DDR5, USB 4. MIPI, DeFi, MIPI M5. What else? Interconnect chiplet controller too. Yeah, I think it's a good list already. Yeah.
Yeah, yeah, it's a good round of list. And next one is what infrastructural resources like tools, licenses are minimally required to build a IP from scratch?
In terms of tools, so here we're talking about EDA tools. You have three main actors. So Cadence Design Systems, Synopsys, and Siemens. So if you do consider a hard IP, you will need a tool for simulation. You will need a formal verification tool, a synthesis tool, place and route tool, equivalence checking tool, tool for testing, timing analysis tool, sign-off power analysis tool, sign-off physical verification tool. I think that's a list of tools, yes. With regards to license needs and operating system environment, it will be based on discussion with the EDA provider, EDA tool provider, because it really depends on the tool versions and tool types. So yeah, I cannot comment further on it.
Yeah. Now, if someone is heading up to start, what skill sets and role should a company hire for effective IP development?
Um, you need which people in your team you need. You will need a RTL architect for sure, engineer, RTL architect engineer, verification engineer too, front-end engineer, back-end engineer, and DFT expert. So you need to be sure that you have complementary skills within your team. Sorry, and you need also, I would suggest also to have some overlaps in the skills of the different people because it will facilitate communication within the team and brainstorming during your meetings.
Sure. As you discussed about formal verification previously, I have a question on it. How
Mhm.
important how important is it to have formal verification, and what are the best practices around it?
I'm not a great expert on this specific topic, but formal verification is a powerful method to ensure that your the design correctness. It improves the reliability of the IP, and because it reduces the debugging cost, also it's a powerful method. Um, and chip designs continue to grow in complexity, right? So adopting formal verification alongside traditional simulation techniques is essential for high quality semiconductor products, I would say. But I cannot go deeper. I'm not a real expert here.
Yeah, we understand. And shall we go to next one? That is, how much effort should be put into IP documentation, and what key documents should be delivered with an IP for legal compliances, and all these things.
Mm-hmm. In terms of documentation, so my first sentence will be IP are meant to be used by others, right? So you need a detailed documentation at every stage of the life cycle of your IP. It's very important. The vendor who provides the IP will standardize. You have to standardize the way the documents are done, the formatting of documents, and their nature over the whole organization. So you need to be clear on that. For specific applications such as automotive or space, you will need ISO certification too. So this need to be included in the documents, and you have to document also the customers' quality expectations and requirements. So the features and the capacities of your IPs need to be well explained through the document, and you need to create a detailed quality plan that outlines the process and standards that and the used methodologies done to make your IP. That's all I can think of, and of course having meaningful pictures of the block of the different blocks of your IP, meaningful qualification, and meaningful tables with the different communication protocols being used, and the data flow speeds and so on should be also part of the documents.
Sure, that was really insightful. And um, how do we recommend approaching IP quality sign off to meet customer expectations?
Um, Okay, so all the customers will expect performance and reliability. So it is best to have 100% code coverage, less area, expected frequencies, of course, and low power consumption is also a key metric nowadays. Testing and validation should be done to be sure that the IP meets the functional and performance requirements. You need to use an established quality methodologies, quality check methodologies and standards which are relevant to your industry. You need to obtain formal sign-off from the customer, confirming that your IP meets their expectation. So it's really a discussion to have with the customer through the IP lifetime, and at the end, you really need the acknowledgement of the customer that it is what they were expecting. And then you need to provide support and maintenance post sign off to address any issues that may arise. And you need to guarantee that there is a process in place for handling any future updates or changes required for your IP.
Yeah, that was a good explanation. And how customizable should an IP be to maximize its current market reach?
Tough question. Need to understand the needs or preferences of your target audience. I think it's crucial because different markets or segments will require different levels of customization. Also, different regions may have different regulatory requirements that will necessitate some level of customization. You need to ensure that the customization does not dilute the brand or the brand of the company or confuse customers. It may be a risk. You need to leverage technology to offer customization options efficiently. I would say digital platforms can provide scalable solutions for customizing IP without significantly increasing the cost. And maybe look at the competitors and see how they have balanced customization with standardization. It will give you good insights into what work well in your industry or in your market.
That was cool and nice. Um, let's go to next question, which is what IP business models works better, perpetual licensing or royalty based? This is for EDA licensing.
Yeah, I understand this question. Perpetual licensing might be more suitable for IP with proven track record, where the market demand is well understood and the licensor prefer immediate revenue and lower administrative overhead. In the other hand, the royalty-based licensing could be more advantageous for innovative or unproven IPs, where the potential for high sales exists but is not guaranteed, because royalty-based licensing allows the licensor to benefit from the IP success over time. So in practice, many IP owners use a combination of both models, such as an initial licensing fee followed then by royalty payments to balance upfront revenue with ongoing income potential.
Cool. That will help a lot of people. And my final question is, what are the top mistakes new IP vendors make when entering the market?
We all make mistakes, right? This is how we learn. So some mistakes I can think of is underestimating the market needs, developing IPs that doesn't meet customer expectations. So this is a more obvious mistake that can be done. Then you may have inadequate verification and quality assurance, skimping on verification processes that can lead to IPs that has bugs or performance issues. This is the second mistake I could think of. Then it can be poor documentation and support, because customers need from the IP vendor a clear, comprehensive documentation and responsive support to effectively integrate and use the IP. Another mistake will be to ignore industry standards, so your IP is not cannot be used. Or maybe another mistake could be to offer an IP that is too rigid and not customizable. This may be a drawback for end customers, because they often need to tweak IP to fit their specific requirements. And maybe another mistake will be a lack of partnerships or a lack of ecosystem networking also. This is all mistakes I could think of.
That was really insightful, Bertrand. You really told all the questions, and Q&A is now completed, and you made it very successful, and your knowledge will help a lot of people. Um Now let's end this for with a greeting to you. I would remind a slogan which is given by Helen Keller. Alone we can do so little. Together we can do so much.
It was my pleasure to share knowledge, and
Yeah.
I think it will help a lot of people going into IP market. I'm not a full expert. Of course, there are plenty of things that can be said, but yeah, I think for a start, it's a good Q&A.